This week in the classroom we're going to be working with equivalent fractions, but I'm going to be using a few other words while I'm teaching. I'm going to be using the word ratio and proportion because even though these words technically have different definitions, when the kids figure them out, they pretty much do it the same way. So if they understand equivalent fractions, they do understand ratios and proportions. The first one we're going to start with today is one like this. It says 3/5 equals blank over 15. And of course, children have to determine what x equals. The way I've taught them to do this is to multiply 3 times 15 and get 45. Then to divide 45 by 5 and get 9. And that would be x equals 9. Now I know that there are some of us that have been taught to divide 5 into 15 and then you get 3 and then multiply times 3. The problem with that method is, suppose this is not 15 but it's 17. See, 5 doesn't divide into 17 evenly, and so children that have been taught that way, for the most part, leave problems like this blank. If they do it the way I just showed you, though, it goes like this. 3 times 17 equals 51. And 51 divided by 5 equals 10 and 1/5. You see, they can get an answer no matter what the numbers are. It's very important that they have a method that will work for them every time. That way they don't get frustrated, again, they don't guess, and worse yet, they don't just give up. Now, of course, in the past I've had children who have said, but that's more work to do it that way. Well, actually not. Let's look at it. Because using that method, they would say 5 into 15, so here you go, 15 divided by 5 equals 3, then they take that 3 and multiply it times the other 3 and get a 9. No problem. Using the method that I'm asking them to use, they actually say 3 times 15 equals 45, and then they take that 45 and divide it by 5 and get 9. You see, the other method, you divide first, then you multiply. This method, you multiply first, then you divide. The difference between the two is none, as long as the numbers are real simple like this. But as soon as this turns to 17 or something that's not evenly divisible, well, this method stops working. And so for that reason, I prefer that the children use this method. Multiply first, then divide. When we work with fractions like this, sometimes they're given one like this, and they're asked, is this an equivalent fraction? An equivalent fraction, this means that 1/2 does equal 2/4. We know that. You can easily see that this was doubled and this was doubled. But the way that we have them determine this is one of two. One way is to multiply across like this. 1 times 4 equals 4. And if we multiply this one and it gets the same product, then this is an equivalent fraction. The 4 is not part of the answer. The 4 is just basically a test. The answer to this question would be yes. This is an equivalent fraction. To give an example, if we had it like this, and they wanted to know, does 1/2 equal 2/3? Obviously, using that method I just showed, you'd say 1 times 3 is 3, and 2 times this is 4. The products are not the same. The answer is no. This is not an equivalent fraction. They do not equal one another. Another method for determining if it's an equivalent fraction would be to reduce both of them to lowest terms. Obviously, 1/2 is in lowest terms, so its lowest terms are 1/2. If we reduce this one to lowest terms, it equals 1/2, and 1/2 equals 1/2, meaning it is an equivalent fraction. That's a second method. Some of the children find reducing fractions a little more difficult than just straight multiplication, so I really do recommend that they just multiply across like this. 1 times 8 is 8, and 2 times 4 is 8, and the answer again to this one is yes, equivalent fraction. Another way that they might be asked the question on, say, a standardized test, would they be asked 2 gallons of white, 3 gallons of red, makes 5 gallons of pink. Okay, so 5 pink. They would say, using this proportion, how many gallons of each would we need to make 20 gallons of pink? All right, well, thing to remember on a problem like this is, again, on a standardized test, one of these four answers is actually correct. So sometimes it pays to just go ahead and solve it that way. Let me show you what I mean. 11 and 20 is 31 gallons. 31 gallons is not going to be correct because how we got 5 was by adding 2 and 3 together. So we had 11 and 20, we get 31. Certainly is not it. This one's possible because 9 and 11 does equal 20. So what they do now is they take this 2/3, does that equal 9/11ths? If we use the equivalent fraction model I showed a minute ago, you multiply across like this and you get 22. You multiply across like this, you get 27. The answer is no. This, although does makes 20 gallons, it is not in proportion with this. And so this can't be our answer either. And we move on to the next one, and you say 2/3 equals 8/12ths. You cross multiply again, you get 24. Cross multiply here, you get 24. This is the answer. Now, I realize that that's not actually showing them how to make a calculation, but that's a test-taking strategy called back solving. And in many ways, it's just as important to your child to know test-taking strategies as how to come up with an actual calculation. Something to think about. And now, by way of review, I started today by explaining how they are going to figure out a missing number. So we have one like this, let's say. We're going to multiply across like this. 1 times 4 equals 4. We're going to take that 4, we're going to divide it by 2, and it's going to equal 2. And that's what x will equal. I've already explained why I think it's important that children do it this way. And then we went on and we determined equivalent. If we have an equivalent fraction. Again, if we have 1/2 equals 4/8, what they do is they multiply across like this and they get 8, and across like this and they get 8, and if both of these products are the same, you have an equivalent fraction. An example of one that's not, we said 1/2 equals 2/3, and when you multiply across you get 3 and 4, and because these two products are not the same, this is not an equivalent fraction. The last thing we did, we talked a little bit about proportions. Let's say we have 5 parts gasoline, 8 parts something else, and we're making a mixture for, say, jet ski fuel. And obviously, you know, I don't know anything about jet skis. But let's say we decide that we want to make more of this. We multiply across like this, and we say 5 times 16 equals 80, and 80 divided by 8 equals 10. Now, again, I'm not sure what I just mixed, but I do know the proportion is correct. That's about all we have for today. I'd like to thank you for watching my video. Remember, as always, that you can re-watch it if you need to, and certainly you're welcome to call me at the school if you have any other questions. Thank you.